Animation derived from a variety of sources often looks stale or lifeless. In this paper, we present the cartoon animation filter, a simple filter that takes an arbitrary input motion signal and outputs motion data that is more alive or animated. The animation filter adds anticipation, exaggeration, and follow-through, along with squash and stretch deformations, all within the same framework. We apply the filter to motions ranging from hand-drawn trajectories to motion-captured degree of freedom curves and video segmentation results. Here we see a simple motion curve for a ball that stands still, then moves from left to right, and then stops. Now we convolve this motion with the LOG filter. The resultant curve shows the anticipation phase, the exaggerated movement, and the follow-through that naturally results from the three-lobed filter. In the resulting motion, the ball pulls back slightly before moving and springs back to rest in the follow-through. Squash and stretch can be achieved with the same filter. The only change is a time shift when applied to points on the boundary of the object. The filter applied to points at the leading edge is shifted earlier in time, thus these points anticipate the impending acceleration. Trailing edge points are affected later. This results in effective squash and stretch. The animation filter can be applied to animation derived from a variety of different sources. This simple drawn animation of a ball seems stale and lifeless. Here is the exaggerated version after applying the filter to the centroid only. And here is a version with exaggeration and with squash and stretch. PowerPoint animations can also be enhanced. Here is a simple presentation to show off pictures from a recent trip to Venice. Here is the exaggerated version with squash and stretch. Last year we saw the ability to extract cutouts from video. Once extracted, the objects are simply two-dimensional shapes per frame. These shapes can have the same filter applied to enhance their motion. We see the original footage and exaggeration with squash and stretch. In a side-by-side version, we can more closely observe the differences. Here we have cut out the girl on the monkey bars, filtered the motion, and reinserted it onto the same background. Surprisingly, the filter can also be applied to animation generated by a motion capture system. We can see the original motion captured walk along with the filtered version offset from it. This golf swing example has two distinct phases, the stance and the swing. As described in the paper, the width of the filter automatically adapts to the changing frequency of the motion. In this final example, we show a boxer, both the original version and the filtered version. The only control the user needs to specify is the amplitude of the filter. Thus we can get more subtle refinement or really go over the top. We have shown how a uniform application of a very simple filter can enliven a wide variety of motions.